Everyone, and welcome to Ellipse Day 1. Today we are going to talk about their different pieces and their formulas. So we see on here some different vocab when it comes to an ellipse. And an ellipse is basically like an oval shape. Officially could be written as like the equation of an ellipse that looks like a circle, but usually they are either going to be a little bit longer or a little bit wider than a traditional circle would be. So there's some different pieces that we have here that make them up. The first being the major axis. So we see on this horizontal shaped parabola, major axis is going to be horizontal, but it could also be, in the case of a vertical one, the taller. Either way, the major axis is always your longer axis. This is going to be 2 times parameter A. Or another way of thinking about this is it's going to be the distance from your vertex to your other vertex. The semi-major axis then is going to be basically half of our major axis. And this is just basically the length of parameter A, without doubling it, A. And you could think about this as the distance from the center to a vertex. It would be the same distance to either vertex. Now our minor axis, in this case that's kind of our vertical one, this is always going to be the shorter of our two axes, and this is always going to be 2 times parameter B. Another way of thinking of this is going to be the distance from a covertex to a covertex. And our semi-minor, axis is again half of the minor axis length. So this is going to be just parameter B, not double it. And you could think about this as, again, the distance from the center this time to one of our covertex. Now the center of the circle is going to be directly in the middle, and we see that this is represented with H comma K, kind of like our center of a circle has been used in the past, and this is going to always be the midpoint of your vertices or the co-vertices, if that's what's given, or the foci. That's always that kind of the midpoint in between there. Now, speaking of foci, these are 2 points that dictate how wide / skinny our ellipse is. The foci are always going to be represented with parameter C. Okay, the distance between them would be 2C. These are always located on the major axis. They will be kind of inside of the vertices. So you notice this example up here, we have our 2 foci, or one singular focus, and they're located on that major axis, always with the vertex. Now speaking of the vertex again, these the vertices are going to be the endpoint of a major axis. Co-vertex is going to be the endpoint of a minor axis. And when it comes to then finding some of these different parameters, okay, we have to get the values of parameter C, aka our foci, it's going to be found by taking the A parameter squared minus B squared. So the key here is always remembering that A is always going to be the biggest parameter for an ellipse. Okay, that vertice, that distance between the vertex and our center, or the length of our major axis, is always bigger than the other axis. Now, when we have our equations, okay, they are always going to start x minus h, y minus k, those squared, and be equal to 1. And notice that they are always being added together. What will dictate if this is vertical or horizontal is going to be where parameter A is at. Because if it is longer than it is tall, A is going to be underneath the x values. If it's taller than it is wide, our A value is going to be under the y's. And then parameter B, okay, our covertice, our minor axis, would be under the other. Okay, so you always are looking for where is my biggest parameter. Now again, the major axis length is always 2 times A. So in this case, the major axis would be the x value, so it's going to again be wider. If it's going to be a vertical, it would be taller. And our minor axis then is always going to be 2 times parameter b. That's the length of that. Our center for both of these again is h comma k, very similar to the center of our circle, or think about the vertex of our parabolas. Our foci then are always going to be on the major axis. So in this case, we would be taking whatever our x, aka h value is, and you would add and subtract that parameter, to move left and right. In the other one, for the vertical, we'd be moving up and down, so you'd be taking your k value and adding or subtracting c to it. So let's look at some of these examples and actually start plotting some of these. Okay, so our first one, we see our equation. Our center is going to be at 2, -1. And if we start looking at where parameter A is at, the bigger number is under the x value. So that's going to be 5. So if we start looking at our picture, we can plot that center at 2, -1. It's under the x's, so we would move x values. We'd have to be going to the right 5 units and to the left 5 units to get the endpoints of our major axis. So that's going to be located at 7, -1 when we went to the right, and -3, -1 when we went to the left. Now the length of that major axis is always 2 times the value of parameter A, so in this case it would be 2 times A. Now parameter B is then found underneath, it's the smaller of the two. B squared is 16, so B, if we square root that, would just be 4. So each of our other points then are going to be 4 units for the covertices, 4 units up, 4 units down from our center, so that our covertices, the minor axis, they are going to be located at 2, 3 when we went up from the center, and 2, -5 when we went down from the center. And this is again going to be, the length of that is 2 times our b value, it's 8 units long. Now parameter C is going to be found by taking our a squared value, c squared will be, and then subtracting away the b squared value. So c squared is 9, that means c would just be 3. So this time it's going to occur on our major axis. It's always going to be the same axis as our vertices, and that would make us move to the left and right 3 units. So we would end up at -1, -1, and our other point would be at 5, -1. And then to finish out our ellipse, we always just connect those vertices and covertices. We see our little horizontal ellipse. Our next example, we end up with a center point this time at -3, -3. Our a parameter, this time our bigger value, a squared, is 49, which means our a value is just 7. Now notice this time this is underneath the y values. So we're going to end up going up 7 from, -3, 3. Should actually be up here. 1, 2, 3, 1, 2, 3, sorry, here. And we're going up 7 and down 7 from -3, 3, so that our vertices are at -3, 10, and -3, -4. Covertices then are going to be found using parameter b. B squared is 1, so the square root of that is also 1. So we're just going to the right and the left of -3, 3, so that we're at -4, 3, and -2, 3 for those. And again, we just kind of connect those dots to get our very tall and skinny this time ellipse. So the length of the major axis is going to be 2 times parameter A. That was 14 units long. The length of the minor axis, we only had 2 times B. That's just going to be 2. Foci this time can be found by first finding parameter C. Remember, A squared minus B squared is going to be parameter C. So in this case, C squared is 48. Square root of 48, which is approximately about 6.9, would be our parameter C. So we're going to have foci values really close to our vertices this time. So we're still at -3, but we took our value of 3 and we added square root of 48 to it, or you could add 6.9. And then we also subtracted square root of 48 from that to get our foci locations. All right, last example that we are going to do together, we see a center this time at -4, 0. So we see our center point here on the x-axis. This time parameter A squared is 16, so if we square root that, we just get 4. Notice these are underneath the y's, so we're going to go up 4 and down 4 to get our 2 vertices at -4, 4, and -4, -4. All right, the length of that axis then is 2 times parameter A, so 8 units total. Now this time, notice there isn't really a B squared value given in our equation. That's because the assumption is there that it is 1, square root of 1 is 1. So we would be going to the right and the left 1 unit, so that we end up at -5, 0 and -3, 0 as our 2 covertices. And 2 times the length of B will give us the length of our minor axis. So this time that is 2 units. Now, last but not least, we want to find those foci. So we are going to take A squared minus B squared, and we end up with the square root of 15 as our final value. So the square root of 15 is, is about 3.9-ish. So we are going to be going up and down because it's still on that major axis, about 3.9 units. So we would be taking -4, but we would be going up 3.9 or up about square root of 15, or we would be going down about square root of 15. Again, you could use the decimal approximations as well. All right, the last one is for you to try. Okay. Thanks everyone for watching. We'll work more with these in class.